Okay, we would like to find the derivative of the square root function, z to the power 1/2, the principal branch of the square root function. So we're going to first take the complex plane here, and we're going to make the slit, the complex plane minus the non-positive real axis. So we're removing these points from the plane, so that's called the slit plane. And that way this function will be continuous in the slit plane, and it will have a derivative as well. So we take a point z0 in the slit plane, and we want to find f prime of z0. And the theorem that we're going to use says that f prime of z0 is equal to e to the minus I theta 0. So this point z0 has a polar form, r0 e to the I theta 0, and then times u sub r at theta 0 r0 plus I v sub r at theta 0 r0. Okay, so again our function is the square root of z. So f of z is equal to z to the 1/2. We expect f prime of z to be 1/2 z to the minus 1/2 if the power rule is going to hold, as it does for real variables. So let's see what happens. We need u sub r and v sub r. So we have to write our function in polar form. So z to the 1/2 is z is r e to the I theta. Let's write that first. Just z is r e to the I theta, and that means then that z to the 1/2 will be r to the 1/2 e to the I theta over 2. And now we can calculate u sub r and v sub r. Let's flesh this out a little bit more. This is r to the 1/2 times cosine theta over 2 plus I sine theta over 2. And we can distribute the r to the 1/2. R to the 1/2 cosine theta over 2 plus I times r to the 1/2 sine of theta over 2. So there's our u plus iv, the real part, plus I times the imaginary part. And we've written the function in polar form, so we can compute the polar derivatives u sub r and v sub r pretty easily. U sub r, the derivative of r to the 1/2, this is a real variable. We can use the real power rule. 1/2 r to the minus 1/2. Cosine theta over 2 is a constant. And then we have v sub r is 1/2 r to the minus 1/2 times the sine of theta over 2. Okay, so then the theorem says that the derivative of our function, so the derivative of z to the 1/2 f prime of z at a point z0 is e to the minus I theta 0 times u sub r, and u sub r has theta and r in it, but instead we'll put, which we can think of as variables, but instead we'll pick the particular theta and r associated with z0. So u sub r is here, and we'll just replace r and theta with r0 and theta 0. So 1/2 r0 to the minus 1/2 cosine theta 0 over 2, and then plus I v sub r, and v sub r is here, 1 half r to the minus 1 half, r0 to the minus 1 half, sine of theta 0 over 2. So there's our derivative. Let's clean it up and see if it turns into 1 half times z to the minus 1 half. So we can factor out 1 half r0 to the minus 1 half, and then we're left with e to the minus I theta, theta 0, and then we're left with cosine theta over 2 plus I sine theta over 2, which is the same as cis theta 0 over 2, which is e to the I theta 0 over 2. We want to put it in the exponential form, and that way we can multiply these most easily. So this is 1 half r0 to the minus 1 half, and then e to the power. We have to add the exponents here, and it looks like we have negative theta 0 over 2. And if z0 is r e to the I theta 0, then z0 to the minus 1 half is r0 to the minus 1 half times e to the I theta 0 over 2, e to the minus I theta 0 over 2, which is exactly what we have here. So this is 1 half z0 to the minus 1 half, exactly as we would have expected from the power rule. So this is a very long and convoluted way, using the polar form of the Cauchy-Riemann equations to get the derivative of the square root function and to see that it just agrees with the standard power rule.